Hello friends, welcome back to my YouTube channel. Today I'll be discussing design of column supported roof for a vertical cylindrical storage vessel. So this is continuation of my discussion on design of storage vessels. In general, this is part 7 of my discussions on storage vessels. In my earlier videos, I have discussed various aspects related to storage vessels. You please watch those videos. I am giving links to those videos in the description section. In my previous video lecture, that is part 6, I have discussed design of a self-supporting conical roof for vertical cylindrical storage vessels. And in part 5, I have discussed design of shell for that vessel. Okay, so this is a continuation of design of storage vessels. So now we will understand how a column supported roof can be designed for a storage vessel, for a vertical cylindrical storage vessel. So let us start. So let us start the discussion. So design of a column supported roof. A column supported roof, it may have different shapes, like it could be conical, it could be dome shape, or it could be an umbrella shaped. We are going to concentrate on a column supported conical roof. So we will be discussing, or I will be discussing design of a column supported conical roof. The design of a column supported conical roof is discussed in this video lecture. Now in the case of a column supported conical roof or column supported conical roofs, uh, what is the case? Columns are used. Columns are the elements that transmit the roof load to the tank bottom. So whatever the roof is, the roof may be subjected to various loads like superimposed loads, dead loads. So all those loads, they will be transmitted. They will be transmitted to the bottom of the vessel by those columns. So they will be transmitted. The columns will be transmitting the load of the roof to the bottom of the vessel. So this has to be kept in mind. In case of column supported conical roofs, columns transmit the roof load to the tank bottom. Okay, the number of columns used, it will of course depend on the diameter of the vessel. So just let me erase it. So what we are saying, the number of columns used, it depends on tank diameter. So for small tank diameter, even one column is sufficient. Even one column is sufficient to support the roof for small diameter tanks or for small diameter vessels. But for large diameter tanks, multiple columns are required. You need to use multiple columns. Multiple columns may be required to support the conical roof. For a roof supported by a single column, the column is usually positioned at the center. So if you have a small diameter storage vessel and the roof is supported by a column, one column is sufficient, and if it is a single column, it will be positioned, or it has to be positioned at the center. For a roof supported by multiple columns, the columns are positioned along a ring of girders. So there will be a ring of girders. I'll show you the schematic, you'll understand over there. So the columns are supported along a ring of girders, and this ring is formed from 5 or more girders. So one ring, it is formed from 5 or more girders. So you please read this as from. The ring is formed from 5 or more girders. So there will be a ring of girders and columns will be supported all along the ring of those girders. And a single ring, it is formed from 5 or more girders. When I will show you the schematic diagram, you'll understand that. Okay. So for example, let us look at a roof that is supported by a single column. So as I said earlier, the column is positioned at the center. So you have this tank, the conical roof for the tank, and if it is a small diameter storage vessel, then there will be a single column, and then this column will be positioned at the center. So now you are looking at a small diameter storage tank which has a conical roof that is supported by a single column, and the single column is positioned at the center. Okay. Now let us look at roof that is supported by multiple columns. So as understood earlier, these columns are positioned along a ring of girders. The ring is formed from 5 or more girders. From 5 or more girders. Uh, these girders then are joined end to end to form a polygon support for the rafters. So there are two basic important elements involved in this case. You have girders and rafters. Girders will be forming a ring, and this ring will be a polygon, regular polygon, and this ring also acts as support for the rafters. Now let us look at the schematic diagram. Now you see the storage vessel. You are looking at it from the top. Okay, so you will have these girders connected end to end, and now you can see a pentagon is formed. Then these are supported by this ring of girders support this rafters. These rings support these rafters. You can see these are the rafters. So ring is acting at the support. So at the end of this rafter, you have another ring of girders. They are connected end to end, and what is resulting? A polygon is formed. A polygon is formed by these girders. You can see these are the girders. I can mark. So these are the girders. So girders, they are joined end to end to form the polygon structure. So even this pentagon is formed from girders, and these are the rafters. These are the rafters. So rafters, they are supported on the ring that is formed from girders, and as you say, at least 5 girders will be there in the ring. 5, it could be more, but at least there should be 5. Then columns will be joined at these points. So for example, this is one column, this is second column, third column, so and so forth. So these are columns that are attached at the joints where rafters are joined to the girders. So at their joints, these columns will be uh, joined. Okay, so in this way, the entire roof for a large diameter storage vessel will be supported by multiple columns. I hope this is clear to you. And if you look at the vessel from sides, So it will be looking like this. So you will have one column at the center, one column at the center, and then other columns will be placed accordingly at appropriate distances. In this way, multiple columns will be supporting the vessel, and this will be the case for storage vessels with large diameters. So what you have to remember at the end of this discussions, in case of column supported conical roofs, number of columns depends on diameter of the vessel. So for small diameter storage vessels, even a single column is sufficient. So you can position that column at the center, and in this way you can support the conical roof. But if you have large diameter vessels, large diameter storage vessels, then we need multiple columns, and those multiple columns will be supporting the conical roof with the help of girders and rafters. So girders, they will be forming a ring which is actually a polygon. This polygon then supports the rafters. There will be at least 5 girders in one ring, and then more than 5. At the joints where girders and rafters are connected to each other, columns are also joined. So in this way, the conical roof will be supported by multiple columns. I hope this is clear to you. If you have any doubt regarding this, you please mention that in the comment section. ठीक, now let us move ahead. Uh, Now for such columns, roof plates are designed. You have to design roof plates so that their bending is prevented. So you have to design the roof plates to prevent their bending. Bending should be avoided, and in order to avoid bending, a proper design has to be done for the roof plates. For designing uh, to prevent bending, what is done, they are designed as rectangular plates. So those roof will be formed from multiple rectangular plates, and in order to prevent their bending, they are designed as rectangular plates. What is the meaning? We are talking about rectangular plates that are uniformly loaded and freely supported at the edges. So the roof plates will be designed as if they are rectangular plates like this. They are rectangular plates, and they are uniformly supported. Uniformly loaded. The load on each roof plate is assumed to be uniform, and plus it is assumed that they are freely supported at the edges. They are freely supported at the edges. So for column supported conical roof, the roof plates are considered to be rectangular plates. They are assumed to be uniformly loaded, and they are assumed to be freely supported at the edges. Okay, so I hope this is clear to you. Let me erase it so that you will be able to understand. Just give me a minute. Okay, the rafters and girders, which are again important elements in case of column supported conical roofs, they are designed as uniformly loaded beams. They are designed as uniformly loaded beams that are freely supported at the edges. So the rafters, they will be designed as beams that too uniformly loaded, and that are freely supported at the edges. So all techniques associated with uniformly loaded beams that are freely supported at the edges will have to be used for designing rafters and girders. The length of the rafter is limited to 6 meter. So you cannot have length for the rafter that is greater than 6 meter. The column supports are designed based on a formula given by Rankine Gordon. So the column supports, they are designed based on Rankine-Gordon formula. I'll tell you what is the formula in my next slide. So you have the column supports, they are designed by Rankine-Gordon formula. What is the formula? The formula is like this. PT, that is total load on the roof, is equal to permissible stress into A. Let me first discuss the formula. So this is PT is equal to FP into A divided by 1 plus A into LE by K square. So what are the terms involved in it? You have PT is the total roof load. You already know how it is calculated. Then FP is the permissible compressive stress. A is cross sectional area for the roof. Small a is a constant. L is effective length. I will tell you how to measure that. So L is effective length and K is radius of gyration. Now the effective length is measured in this way. What is that? This is effective length is the distance between 2 points of inflection. So for example, this is a column that is supported at its end, and if load let L be the length of the column, if it is acted upon by total load PT, then under the influence of total load it may bend. So the point of inflection will be the points where bending will be occurring. So for this particular beam column that is supported at its end, point of inflection will be at the end itself for this type of column that is supported at both the ends. For other beams, point of inflection will be at different locations. So you can refer that for that you can refer any book on that to understand that. So we are concerned with columns that are supported at its ends, freely supported at its end. So the distance between inflection point will be the effective length. For this column, length of the column and its effective length is the same. So for designing columns, for column supported conical roofs, the effective length will be equal to length of the column. Then how to use this formula? Total load will be calculated. Total load will be estimated first. Permissible stress will be known to us. Area, cross-sectional area will be known to us. So you can just find the dimension. You can get the cross-sectional area. You can get the effective length. One more parameter in the equation is radius of gyration. Radius of gyration. What is this radius of gyration? This radius of gyration, it gives the distribution of cross-sectional area in the column around its centroidal axis. So if you represent a column where the two horizontal and vertical axis meet each other, so you'll be having centroid over there, and this will be the centroidal axis. So radius of gyration gives distribution of the cross-sectional area about the centroidal axis. So if let us say that h is the height of the column, and then this is b, then radius of gyration will be given as b under root of b upon 2 root 3, 2 into root 3. So if b is known to you, if this dimension is known to you, you can calculate radius of gyration and then you can use it in the formula. So basically what you have to remember, we are not going in this particular video lecture, I am not going to discuss column supported conical roofs in details. My objective was to discuss self-supporting conical roof. I have done that in my previous video. You please watch it. Just to summarize how column supported conical roofs are designed, I am discussing this. So the main formula for designing column supported conical roof is this one. So you have to use it to design column supports. ठीक है, so that is the end for my discussion. That is the end of my discussion on column supported conical roofs. It was a brief summary of the design procedure that is used for designing column supported conical roofs. Thanks for watching my video. Do subscribe to my YouTube channel. Be with me and hit the bell icon so that you'll be notified as soon as I upload any new video on my YouTube channel. My objective is to uh, cover various aspects of chemical engineering on my YouTube channel. So please be with me. Thank you. Have a nice day. Bye bye.